You've never once felt yourself move through the vastness of the cosmos. You sit completely still in your room, feeling the solid ground beneath your feet and trusting that you're perfectly stationary. The world around you seems peaceful and permanently anchored in place. But this comforting stillness is the greatest illusion your senses have ever created. You're actually plummeting through an endless void at terrifying speeds, dragged along by a violent gravitational river. Your entire planet, your star and your galaxy are being violently pulled toward a massive unseen basin hidden in the dark. You're continuously plunging into a cosmic abyss without ever feeling a single breeze, helplessly falling while sitting perfectly still. This absolute disconnect between your everyday senses and the true physical reality of space is exactly what we're going to explore. For thousands of years, humans have tried to map out this terrifyingly vast structure, only to discover that our intuition fails us at every single step. We're trapped on a tiny rock, trying to comprehend dimensions that make our entire solar system look like a microscopic grain of dust. The scale of the cosmos isn't just unimaginably large, it operates on mechanical rules that shatter the very limits of human logic. Today you'll find out what the observable universe really is, and why the galaxies we see at its edges are physically impossible to ever reach. Before we set off, one question for you. Where in the world are you watching the sky from, and what time is it where you are? Tell us down in the comments. And if you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. Let's step into the cosmic dark. To understand the terrifying scale of the universe, we first have to look at a time when the cosmos felt comfortably small. For thousands of years, humanity looked up at the night sky and saw a predictable enclosed dome. The stars were nothing more than tiny points of light, pinned to a massive rotating sphere that circled our seemingly central world. But even as early telescopes shattered that ancient illusion and revealed a deeper sky, a new, equally comforting dogma took its place. By the late 19th and early 20th centuries, the brightest scientific minds on the planet had reached a confident consensus. They believed that our home galaxy, the Milky Way, was the absolute entirety of the universe. Every star, every glowing cloud of gas, every wandering comet was firmly contained within this single, sprawling island of light. Beyond the edges of the Milky Way, they assumed, there was absolutely nothing. There was just an infinite, empty and silent void. The intellectual puzzle was essentially solved. So the physicists and astronomers patted themselves on the back, convinced that they had successfully mapped the ultimate boundaries of reality. We knew exactly where we lived, and we knew that our galactic backyard was the grandest stage in existence. Everything was neatly categorized, and the universe was a safe, manageable place. But this cozy illusion actually had a tiny, almost invisible crack in it, dating back nearly 1,000 years. In the year 964, a brilliant Persian astronomer named Abdul Rahman al-Sufi spent his nights meticulously scanning the heavens. Imagine standing in the dark desert of the 10th century, relying entirely on your own bare eyes to decode the sky. Long before the invention of the optical telescope, using only his incredibly sharp vision and immense patience, he mapped the constellations with unprecedented precision. While gazing at the constellation of Andromeda, his eyes caught something strange. It was a faint, blurry smudge that didn't look like a sharp star. In his monumental work, The Book of Fixed Stars, he carefully recorded this anomaly, describing it simply as a small cloud. He had absolutely no idea what he was looking at, but his meticulous ink drawing was a monumental milestone. It was the first time in human history that anyone had documented the light from an entirely different galaxy. Yet, the profound, earth-shattering meaning of this little smudge remained completely hidden from humanity. For centuries, European astronomers would later observe the same fuzzy patches and confidently dismiss them as local nebulae. They assumed these were just swirling clouds of gas and dust forming new stars right here in our own galactic neighborhood. The dogma was so strong that it blinded generations of observers to the terrifying truth hiding in plain sight. The idea that these clouds might be something more wasn't entirely unprecedented, but it was treated as philosophical heresy rather than hard science. Back in the 18th century, the visionary philosopher Immanuel Kant had speculated that these fuzzy nebulae might actually be massive, independent disks of stars. So, he poetically called them island universes, imagining a cosmos filled with countless galaxies just like ours. But philosophers don't have telescopes, and without hard mathematical data to back up these wild claims, the scientific community easily brushed his ideas aside. The ruling paradigm demanded measurable proof, and the technology of the time simply couldn't provide it. So generation after generation of astronomers mapped the sky, perfectly content to believe that the Milky Way was the ultimate container of all reality. You have to understand how deeply comforting this idea was. It made the cosmos feel like a large but manageable house. We were the sole inhabitants and we had mapped all the rooms. To suggest otherwise was not just scientifically controversial, it was psychologically terrifying. It meant stepping out of a secure, warmly lit house and realizing you were standing in the middle of an endless dark desert with no horizon in sight. As we moved into the early 20th century, telescopes grew significantly larger and far more powerful. They began capturing more light, revealing that these fuzzy patches were actually intricate, spinning spirals. The scientific community started to feel a deep, unsettling tension. The established dogma was cracking under the weight of new, confusing observations, but the academic establishment fiercely defended its cozy universe. This intellectual pressure cooker finally exploded in the year 1920, during what became known as the Great Debate at the Smithsonian Institution in Washington. The entire cosmological worldview of humanity was officially put on trial. On one side stood Harlow Shapley, a formidable and highly respected astronomer defending the established consensus. He argued passionately that the Milky Way was massive. He believed it was perhaps 300,000 light-years across, and that it encompassed absolutely everything. To Shapley, the universe was synonymous with our galaxy. Those weird spiral nebulae, he claimed, were just small, local phenomena trapped inside our own galaxy, perhaps solar systems currently in the process of forming. Shapley's argument wasn't just based on blind faith. He had solid observational data regarding exploding stars that seemed to prove the spirals were nearby. If Andromeda was as far away as his opponents claimed, Shapley calculated that an explosion inside it would have to be impossibly bright, completely defying the known laws of physics as they understood them at the time. On the other side stood Heber Curtis, a sharp and skeptical observer who had spent years staring at photographic plates of these spirals. Curtis looked at the exact same data and proposed something utterly unthinkable. He argued that these spiral clouds were entirely separate island universes, located millions of light-years away. He pointed out dark dust lanes in the spirals that perfectly matched the dust lanes seen in our own Milky Way, strongly suggesting they were structural twins. He also noted that the exploding stars Shapley mentioned were actually much fainter than typical novae, which perfectly explained their immense distance. To Curtis, our majestic Milky Way was not the entire universe. It was just one isolated island drifting in a much, much larger and colder void. We step into that historic auditorium in 1920, and the atmosphere is intensely electric. Two brilliant minds stand on a wooden stage, literally holding the fate of the universe in their hands. Shapley presents his meticulously drawn charts, his voice echoing with the absolute confidence of established science. He assures the crowd that we are the main event, that there is nothing beyond our known galactic shores to threaten our understanding. He offers a universe that is vast yet comfortably bounded. But then Curtis steps forward, pointing his finger at the faint spiraling light of Andromeda captured on large glass plates. He doesn't just see a cloud of gas, he sees a terrifyingly vast reality filled with billions of alien stars separated from us by unimaginable distances. The room falls completely silent. You can almost hear the intellectual foundation of humanity trembling on the very edge of a colossal paradigm shift. If Curtis is right, the universe is infinitely larger than anyone ever dared to imagine, and you are infinitely smaller, reduced to a microscopic speck of dust floating in a dark, uncaring abyss. The debate rages on, filled with complex calculations and passionate arguments, but the evening ends in a frustrating stalemate. Neither man possesses the definitive physical proof required to shatter the opposition. The universe hangs in a tense limbo, waiting for a single undeniable observation to finally break the glass ceiling of our galaxy. But the definitive physical proof would soon raise an even more terrifying puzzle. To understand how we finally solved this cosmic mystery, we have to go back to a freezing night on a Californian mountain. It is the autumn of 1923, at the Mount Wilson Observatory overlooking the sprawling lights of Los Angeles. The physical setting inside the observatory dome is as far from the sterile, comfortable laboratories of today as you can possibly imagine. You have to picture a massive, cavernous room that feels more like a heavy industrial factory than a delicate scientific facility. At the center sits the Hooker telescope, a monstrous machine constructed of heavy steel and iron, housing a 100-inch glass mirror. The air inside the unheated dome is bitterly cold, intentionally kept at freezing temperatures to prevent the massive glass mirror from warping due to thermal expansion. The entire space smells of thick lubricating grease, cold metal, and the faint scent of pipe tobacco. To operate this mechanical giant, astronomers have to physically crank massive gears and navigate perilous platforms high above the concrete floor in near total darkness. Sitting on one of these precarious observing platforms is a 33-year-old astronomer named Edwin Hubble. He is wrapped in a thick, heavy coat, peering intensely through the guiding eyepiece while patiently exposing a fragile glass photographic plate. He's pointing the massive telescope directly at the Andromeda Nebula, the very same blurry smudge that Abdul Rahman al-Sufi had sketched nearly 1,000 years earlier. Hubble isn't just looking for pretty shapes, he is hunting for a very specific, incredibly rare astronomical phenomenon known as a Cepheid variable star. These specific stars are the holy grail of early 20th century astronomy. They act like cosmic lighthouses, pulsating and changing their brightness in a highly predictable rhythm. Because their pulsation rate is directly linked to their true intrinsic luminosity, finding one allows an astronomer to calculate exactly how far away it must be to appear as faint as it does from Earth. Night after freezing night, Hubble takes long exposures, carefully developing the glass plates in the darkroom and comparing them with a magnifying glass. Finally, he spots what he is looking for. In the outer arms of the Andromeda spiral, he identifies a faint star that periodically brightens and dims. He excitedly crosses out the letter N for nova on his photographic plate and writes VAR, in large red letters, marking the discovery of the variable star. He immediately sets to work on the complex mathematical calculations, measuring the star's pulsation period and its apparent brightness. When the final number emerges from his equations, it is so staggeringly large that it completely shatters the known boundaries of reality. According to Hubble's math, this single star, and therefore the entire Andromeda Nebula, is located approximately 1 million light-years away from Earth. To put that into perspective, Harlow Shapley had argued just 3 years earlier during the Great Debate that the entire universe was, at most, 300,000 light-years across. In a single, quiet moment in a freezing observatory, the Great Debate is decisively settled. Heber Curtis was absolutely right, and the established dogma of centuries is instantly vaporized. The Milky Way galaxy is not the entire universe, it is merely our local neighborhood. Andromeda is definitively proven to be a completely separate island universe, a massive swirling disk containing billions of its own stars, floating at an unimaginably vast distance from our own. The universe has just grown by a factor of millions overnight. The scale of the cosmos is suddenly upgraded from a large but manageable room to an infinite, incomprehensible ocean filled with isolated islands of light. You would think that this monumental revelation would be the final, ultimate shock to the scientific community. For a brief fleeting moment, humanity tries to find comfort in this new paradigm. Okay, so the universe is unfathomably huge and filled with billions of other galaxies, but at least it is a stable, static, and peaceful museum. We just have a much bigger map to draw, but the universe wasn't done playing with our minds. Having successfully measured the distance to Andromeda, Hubble and his brilliant self-taught assistant Milton Humason turn the colossal Hooker telescope toward other even fainter galaxies. They begin attaching heavy spectrographs to the telescope, instruments designed to split the faint light of these distant galaxies into a rainbow of colours like a glass prism. By analysing these light spectra, they can determine not only what these galaxies are made of, but also how they are moving through space. What they discover is deeply unsettling. As they analyse the light from dozens of different galaxies, they notice a bizarre, consistent pattern. The light signatures are almost universally shifted toward the red end of the colour spectrum. This phenomenon, known as redshift, is the visual equivalent of the Doppler effect. Think of an ambulance rushing past you on the street. The pitch of the siren sounds higher as it approaches, and then noticeably drops lower as it speeds away. The same exact principle applies to light waves. If a galaxy is moving toward you, its light waves are compressed, shifting toward the blue end of the spectrum. If it is moving away from you, the light waves are stretched out, shifting toward the red end. Hubble and Humason's data reveals an undeniable, terrifying truth. Almost every single galaxy they look at is redshifted. They're all moving away from us. But the shock doesn't stop there. The data shows a strict mathematical correlation. The farther away a galaxy is from Earth, the faster it is fleeing into the dark. It is a relationship so precise that it becomes known as Hubble's law. This means that the galaxies aren't just drifting randomly like ships on an ocean. The entire fabric of space itself is stretching, expanding in all directions simultaneously. The universe is not a static, peaceful museum. It is a violent, dynamic explosion that is still unfolding right before our eyes. Imagine drawing a series of dots on a deflated balloon and then blowing it up. As the rubber stretches, every single dot moves further away from every other dot. From the perspective of any one dot, all the others seem to be rushing away. That is exactly what is happening to the entire cosmos. This realization strikes a profound psychological blow. We are not just a microscopic speck of dust floating in a vast void. We are a speck of dust in a void that is actively blowing apart, diluting itself into an ever colder, ever darker abyss. But this mind-bending solution immediately opens the door to a much darker and more sinister mystery. Let's think about this logically. All these galaxies have immense mass, which means they all exert an incredibly powerful gravitational pull on one another. Gravity is the ultimate cosmic glue. It always pulls things together. Therefore, the collective gravity of all the matter in the universe should be acting like a giant brake, constantly pulling back on the expanding fabric of space and slowing the expansion down over time. Yet as we look deeper and measure more carefully, we face a horrifying contradiction. What kind of dark, unseen, and impossibly powerful force could possibly possess enough energy to overpower the combined gravitational pull of billions of galaxies and drive this relentless cosmic stretching? This massive unresolved question about what is actually pushing the universe apart is a shadow that will hang over our heads until we reach the very edges of our knowledge later in this journey. We had finally shattered the ancient glass ceiling and mapped the immense boundaries of our galactic neighbourhood. But just as the definitive solution arrived, an even more terrifying cosmic puzzle emerged. To fully grasp how terrifyingly empty this expanding universe really is, we have to start by measuring the sheer, unadulterated void right outside our front door. When you were a child, you were almost certainly lied to. If you open any standard science textbook and look at a diagram of our solar system, you will see a bright yellow sun with 8 colourful planets neatly lined up, floating closely together on a single page. You can visually jump from Earth to Mars and from Jupiter to Saturn with just a quick glance. This deeply ingrained educational image has conditioned your brain to think of the solar system as a cosy, crowded neighbourhood. But this representation is a massive comforting lie. born out of pure publishing necessity. If a textbook company wanted to print a scientifically accurate map of the solar system to scale, the page simply wouldn't fit on your desk. For this accurate map, the Earth would be just the size of a standard printed period at the end of a sentence. The paper would have to stretch for several miles just to include the orbit of Neptune. On that miles-long sheet of paper, the Sun would be a small golf ball sitting a few blocks away, and the vast, overwhelming majority of the paper would be completely blank white space. The defining physical characteristic of our solar system is not the planets, the moons, or the Sun. It is the suffocating, unbearable emptiness that separates them. To truly feel the weight of this emptiness, let's perform a radical two-ended comparison. Imagine shrinking our massive blazing Sun, which in reality is 1,000,000 times larger than Earth, down to the size of a single grain of sand sitting on your fingertip. On this dramatically reduced scale, the Earth would be an entirely invisible, microscopic speck orbiting just a few inches away. You might comfortably imagine that the rest of the galaxy is just a handful of sand scattered across the floor of your living room. But if our Sun is a grain of sand sitting in your hand in New York City, the very closest star to us, Proxima Centauri, wouldn't be on the other side of the room. It wouldn't even be in the same building. The nearest star would be another isolated grain of sand sitting somewhere in Atlanta, nearly 1,000 miles away. Between your hand in New York and that second grain of sand in Georgia, there is absolutely nothing. No air, no light, no warmth. Just an endless, freezing, silent desert. This is the true, unfiltered nature of space. It is a profound, crushing emptiness that completely defies human comprehension. Every single star you see in the night sky is separated by this horrifying degree of absolute isolation. Humanity has bravely tried to cross this local desert, but our greatest engineering efforts only highlight our absolute, humiliating insignificance. In 1977, we launched the Voyager 1 spacecraft. It is the fastest, farthest-traveling machine ever built by human hands. As you watch this video, Voyager 1 is hurtling away from us at a blistering speed of roughly 38,000 miles per hour. It has been flying continuously through the dark for nearly half a century. It has travelled so far that it takes light itself, the fastest thing in the universe, over 22 hours just to catch up with it. We often proudly declare that Voyager has left the solar system because it finally crossed the heliopause, the magnetic bubble created by our Sun. But the gravitational grip of our solar system extends much, much further than its magnetic shield. Waiting out there in the freezing dark is the Oort cloud, a massive spherical shell of trillions of icy comets and frozen debris that completely encapsulates our solar system like a thick, dirty rind. The scale of the Oort cloud is so mind-numbingly immense that it makes the distance from the Sun to Neptune look like a microscopic rounding error. Think about the speed of light for a moment. Light from the Sun reaches Earth in about 8 minutes. It takes about 4.5 hours for that same light to reach Neptune. But for the Sun's light to reach the outer edge of the Oort cloud, it takes over a solid year. An entire year of travelling at 186,000 miles per second just to reach the outer fence of our own property. The scale is so massive that the light from our own Sun becomes faint and mathematically useless, unable to even warm a block of ice. Even though Voyager 1 is screaming through the void at 38,000 miles per hour, it hasn't even reached the inner edge of the Oort cloud yet. In fact, it will take our fastest spacecraft another 300 years of continuous flying just to arrive at the inner boundary of this icy shell. And to fully cross it, to actually break free from the true gravitational limits of our solar system and enter untouched interstellar space. That journey will take Voyager 1 roughly 30,000 years. As Voyager continues this eternal coasting, its nuclear battery is slowly dying. Soon, it will lose the power to send even the faintest whisper of a radio signal back to Earth. It will become a completely dead, silent piece of metal, carrying a golden record with the greetings of a species that might no longer exist. It is a monument to human curiosity, permanently swallowed by an ocean of dark nothingness. 30,000 years of flying dead in the dark just to cross the threshold of our own front yard. When, or if, you finally cross that unimaginable boundary, you enter the interstellar medium, the space between the stars. Here, we run into another massive misconception. Popular science fiction has conditioned us to believe that deep space is a perfect, pristine vacuum, an entirely empty stage waiting for spaceships to glide through it effortlessly. But the interstellar void is not empty, and it is certainly not peaceful. It is filled with a very thin, invisible soup of highly charged plasma, lethal cosmic rays, and microscopic silicate dust. This interstellar wind is the violent exhaust of ancient exploding stars constantly blowing across the galaxy. For billions of years, the magnetic bubble of our sun has acted like a cosmic shield, violently crashing against this interstellar radiation and protecting the delicate planets inside. But once you step outside that shield, you're fully exposed to a harsh, radioactive wasteland. The space between the stars is a hostile ocean of energy that would slowly rip apart any unprotected biological material. This is the crushing reality of our immediate surroundings. We are trapped on a microscopic speck separated from our nearest neighbor by an uncrossable desert of radiation, traveling in machines that are statistically standing completely still. We look up and think we are seeing a crowded sky, but we are actually peering through a magnifying glass at an infinitely sparse graveyard. The distances are so vast that human emotion simply cannot process them without shutting down in self-defense. And yet, this terrifyingly empty, hostile wasteland is the most crowded, densely packed neighborhood we will ever visit. To understand our true, inescapable position in the cosmos, we first have to zoom out and look at the colossal island we call home. In the previous step of our journey, we established that the space right outside our solar system is a horrifyingly empty, hostile desert. We stated that this local wasteland is the most crowded neighborhood we will ever visit, which sounds like an absurd contradiction. But to grasp why that is absolutely true, you have to mentally step back and look at the Milky Way galaxy in its entirety. Our home galaxy is a magnificent, swirling, barred spiral structure stretching approximately 100,000 light-years across. It is a gigantic glowing pinwheel containing anywhere from 100 billion to 400 billion individual stars. Let's use a physical analogy. Imagine shrinking our entire solar system down to the size of a single ceramic coffee cup sitting on your desk. This tiny cup includes the vast, icy expanse of the Oort cloud that would take Voyager 30,000 years to cross. On this drastically reduced scale, the Milky Way galaxy would be roughly the size of the entire North American continent. You're living inside a single coffee cup, placed somewhere in the suburbs of a continent-sized structure made of hundreds of billions of other cups, all spinning slowly in the dark. Our sun is located on one of the outer spiral arms, called the Orion Arm, about 27,000 light-years away from the intensely crowded galactic core. It takes our entire solar system roughly 225 million years just to complete a single orbit around the center of this spinning island. The last time Earth was in its current position relative to the galactic center, dinosaurs were just beginning to walk the planet. At the very heart of this continent-sized spinning disk lies Sagittarius A star, a supermassive black hole with the mass of 4 million suns anchoring the entire structure. But despite its unimaginable size and power, the Milky Way is not a solitary wanderer in the dark. It is simply one member of a small gravitationally bound community of galaxies known as the Local Group. The Local Group contains over 50 individual galaxies spread across a volume of space roughly 10 million light-years in diameter. The vast majority of these galaxies are tiny, misshapen dwarf galaxies that are gravitationally tethered to the two dominant heavyweights of our neighborhood. We are one of those heavyweights. The other, sitting approximately 2.5 million light-years away, is the Andromeda Galaxy. Andromeda is our massive, intimidating big sister. It is significantly larger than the Milky Way, stretching over 220,000 light-years across and containing an estimated 1 trillion stars. It dominates the Local Group and its gravitational influence dictates the fate of dozens of smaller dwarf galaxies caught in its cosmic web. Because Andromeda is so massive and relatively close, it is the only major galaxy in the universe that is not running away from us. While the terrifying expansion of space discovered by Edwin Hubble is stretching the rest of the cosmos apart, the localized gravitational pull between the Milky Way and Andromeda is strong enough to easily overcome that expansion. We are inextricably locked in a fatal gravitational embrace. The two largest islands in our local ocean are actively falling toward each other at a blistering speed of roughly 250,000 miles per hour. This brings us to a massively popular and deeply misunderstood scientific myth. You've probably heard or read that in about 4.5 billion years, the Milky Way and Andromeda are going to collide. When most people hear the phrase galactic collision, they instantly picture a catastrophic, terrifying apocalypse. They imagine a Hollywood-style disaster where billions of stars smash into one another, planets are violently vaporized in blinding explosions, and entire solar systems are torn to shreds in a fiery cosmic wreck. But this chaotic, destructive image is completely false. Remember the terrifying emptiness we discussed earlier? Because of that extreme, isolating void between stars, the upcoming collision won't be a violent crash at all. It will be more like two ghosts passing completely through one another. When the Milky Way and Andromeda finally intersect, the vast empty spaces between the stars will easily absorb the incoming populations. The mathematical probability of even two individual stars physically colliding during this entire multi-billion-year process is astonishingly, almost impossibly low. Instead of a fiery explosion, it will be a slow, silent, and incredibly majestic gravitational dance. The two beautiful spiral galaxies will distort, stretch, and eventually merge their supermassive black holes, settling into a single, massive, and featureless elliptical galaxy that astronomers have preemptively named Milkomeda. The night sky of Earth, if our planet somehow still exists, will simply light up with 1 trillion new, harmless stars. But beneath this majestic gravitational dance lies a deeply unsettling, claustrophobic truth. The local group is our permanent, inescapable prison. No matter how advanced our technology becomes, no matter how fast we figure out how to travel, we will never ever be able to leave it. This small collection of 50-something galaxies is the absolute limit of our physical reality. Because of the accelerating expansion of the universe, the void between our local group and every other galaxy cluster is growing wider and wider every single second. Over billions of years, the expansion of space will become so severe that the light from all other galaxies will literally be stretched beyond the point of visibility. Every single galaxy outside our local group will eventually cross a cosmic event horizon, fading to black and disappearing from our sky forever. We are permanently marooned on this specific island archipelago. Our local group will eventually merge into one giant lonely galaxy, completely cut off from the rest of the universe by an ocean of expanding space that is physically impossible to cross. Trillions of years from now, any intelligent beings living in the newly formed Milkomeda galaxy will look up into the night sky and see absolutely nothing beyond their own stars. They will have no physical evidence that the rest of the universe ever existed. They won't know about the cosmic expansion, and they certainly won't know about the billions of other galaxies that once filled our telescopes. The universe will have erased its own history, leaving them entirely alone in a dark, static void. We are trapped in the dark right now, watching the rest of the universe rapidly run away from us, knowing with absolute mathematical certainty that we can never follow. The crushing, claustrophobic realization is that our cosmic neighborhood isn't just a place we live, it is a slowly closing cage, permanently sealing us off from the vast majority of existence. And yet, this inescapable galactic prison is actually falling towards something much darker. To fully grasp how terrifyingly empty this expanding universe really is, we have to push our perspective to the absolute breaking point. At the end of the last block, we established that our inescapable local group is actively falling through the void. It is being violently pulled by a massive gravitational anomaly. Our entire galactic neighborhood is plunging toward the center of the Virgo supercluster. If the local group is a tiny isolated village, the Virgo Supercluster is a sprawling, chaotic metropolis. It contains roughly 2,000 individual galaxies, all swarming around a dense, incredibly violent center. And just like a city, the space between these galaxies is severely polluted. We tend to imagine intergalactic space as a perfect freezing vacuum, but inside a supercluster, it is choked with the intracluster medium. This is a massive ocean of superheated plasma, millions of degrees hot, aggressively radiating invisible X-rays in the dark. The gravitational friction here is so intense that galaxies actually crash and strip each other of their star-forming gas as they fall toward the center. But this violent metropolis is just a single, insignificant neighborhood in a much larger, unimaginably vast structure. In the year 2014, astronomers mapped the complex gravitational flows of our local universe and discovered something breathtaking. Our Virgo supercluster is merely one tiny glowing branch on a colossal structure named Laniakea. In the Hawaiian language, Laniakea translates to immeasurable heaven, and the name is entirely justified. This terrifyingly massive structure spans over 520 million light-years across. It contains roughly 100,000 galaxies, all flowing together like majestic, slow-moving rivers of light. And all these rivers are flowing downward, pouring into a mysterious, dense gravitational basin known simply as the Great Attractor. This is the violent gravitational river dragging us through the dark that we mentioned at the very beginning of this journey. We are a microscopic speck of water in a cosmic waterfall, helplessly cascading toward an unseen abyss. But even Laniakea is just a tiny drop in the ultimate cosmic ocean. Let's address another massive, deeply ingrained myth about the universe. When people try to visualize the cosmos, they usually imagine galaxies scattered completely randomly across the void, like dust motes floating aimlessly in a dark room. But the universe is not random at all. If you zoom out beyond Laniakea to a scale of billions of light-years, a horrifying, almost biological pattern emerges. Let's use a biological analogy. The universe looks exactly like a colossal human brain. It is structured as a complex neural network made of glowing, interconnected filaments. Galaxies do not form randomly, they only exist along these massive thread-like structures of dark matter, forming what we call the cosmic web. Where these threads intersect, you find superclusters like Laniakea. But the most terrifying part of the cosmic web isn't the glowing threads, it is the space between them. These are the cosmic voids, spherical regions of absolute staggering nothingness that span hundreds of millions of light-years across, containing virtually zero galaxies. If the Earth were placed in the center of a particularly large void, like the Bhuta's void, we wouldn't have even known other galaxies existed until the invention of highly advanced telescopes in the 1960s. Our night sky would have been terrifyingly dark. And because of the dark energy pushing the universe apart, these horrifying voids are actively expanding, forcefully pushing the glowing threads of the web further and further away from one another. If we zoom out past the cosmic web, we eventually hit a hard physical limit. We reach the edge of the observable universe. Here we encounter another incredibly common and deeply confusing misconception. You have probably learned that the universe is roughly 13.8 billion years old. Logic dictates that since nothing can travel faster than the speed of light, the absolute farthest we can possibly see should be 13.8 billion light-years away in any direction. That would make the universe a sphere roughly 27 billion light-years across. But human logic fails again. Because space itself has been violently stretching and expanding since the very beginning of time, the light from the most distant objects has had to travel across an expanding surface. The objects that emitted that light 13.8 billion years ago have been pushed incredibly far away. Today, the actual physical edge of the observable universe is 46.5 billion light-years away in every direction. The sphere we live in is actually 93 billion light-years in diameter. What exactly is at this absolute edge? When our telescopes look 46 billion light-years away, they don't see galaxies or stars. They hit a solid wall of ancient microwave radiation. This is the cosmic microwave background, or the CMB. It is the fading, cooling afterglow of the Big Bang itself. You're looking at the exact moment the universe cooled down enough for light to finally travel freely through space. It is a baby picture of the cosmos, taken nearly 14 billion years ago. This brings us to the final, ultimate myth of our cosmic anatomy. When people look at this spherical CMB wall surrounding us, they inevitably ask a very logical question. If the Big Bang was an explosion, where is the center? Where did it happen? Our brains are rigidly wired to think of explosions happening at a specific, pinpoint location inside a dark room, blowing shrapnel outward. But the Big Bang did not happen inside a pre-existing room. The Big Bang didn't happen in space. It happened to space. The very fabric of reality itself exploded into existence from a state of infinite density. Therefore, there is no single physical center that you can point a telescope at. The initial explosion happened absolutely everywhere all at once, meaning the remnants of that explosion are still everywhere. The only reason the observable universe looks like a sphere with Earth at the exact center is simply because light takes the exact same amount of time to reach us from every direction. It is a colossal, inescapable optical illusion. If you magically teleported to a galaxy 40 billion light-years away, you would find yourself at the exact center of a completely different observable sphere, looking at a completely different CMB wall. Every single point in the universe is the exact center of the universe, and while reaching this absolute mathematical edge of existence might seem like the end of the line, the true descent into madness is actually just beginning. To understand why we can never truly explore the universe we see, we first have to understand the terrifying mathematics of expansion. Throughout this journey, we have successfully zoomed out from the microscopic grain of sand that is our solar system. We travelled all the way to the colossal glowing threads of the cosmic web. Finally, we reached the solid wall of microwave radiation that marks the absolute edge of the observable universe. We have meticulously drawn a complete map of reality, a sphere 93 billion light-years across. But this magnificent map comes with a horrific, soul-crushing price tag. What you're looking at is not a living, breathing cosmos. You're looking at a map of a cosmic ghost town. The absolute limits of human exploration have already been firmly set, not by our lack of technological progress, but by the cold, unforgiving laws of physics. To fully grasp this, we have to return to the deeply confusing paradox of the universe's age and its physical size. We established earlier that the universe is roughly 13.8 billion years old, yet its physical diameter is 93 billion light-years. How is this mathematically possible? Albert Einstein famously proved that absolutely nothing in the universe can travel faster than the speed of light. This is the ultimate unbreakable speed limit of reality. If nothing can move faster than light, how could galaxies possibly spread out to cover 46 billion light-years of distance in only 13.8 billion years? The answer lies in a brilliant, mind-bending technicality. The galaxies themselves are not moving through space faster than the speed of light. Instead, the actual fabric of space between the galaxies is stretching and multiplying. Imagine drawing two dots on a rubber band and pulling the ends. The dots aren't moving across the rubber, but the rubber itself is creating more physical distance between them. Einstein's unbreakable speed limit only applies to physical objects moving through space, not to space itself. Space can expand at whatever speed it wants to, and this is where we finally arrive at the central terrifying paradox we promised to explain at the very beginning of this video. The expansion of space is cumulative. Every single cubic inch of empty space is constantly expanding, generating more space. Therefore, the more space there is between us and a distant galaxy, the more new space is being generated every single second. It is a compounding interest of nothingness. Because of this compounding effect, as you look further and further away from Earth, the recession velocity of those distant galaxies drastically increases. At a very specific distance from Earth, roughly 14.5 billion light-years away, the cumulative expansion of space adds up to a recession speed that exactly matches the speed of light. This creates a terrifying boundary known as the cosmic event horizon. Any galaxy that lies beyond this invisible line is currently being pushed away from us by expanding space at a speed that is significantly faster than the speed of light itself. If you were standing in one of those galaxies right now and shined a laser beam directly at Earth, that light would never, ever reach us. The space between us is expanding faster than the light can travel through it, like a swimmer desperately trying to swim upstream against a violently fast river, only to be constantly pushed backward. We are physically, permanently severed from them by the mechanical laws of the cosmos. Before we unravel the darkest, most unsettling implication of this terrifying paradox, drop a comment below. What is the most mind-bending or unsettling fact you have learned so far on this journey? Tell us in the comments. And if you love wandering through the night sky and exploring these cosmic mysteries, make sure to subscribe to the channel. That's exactly what keeps this massive project going. Let's step back into the terrifying reality of the void. Now, let's apply this mathematical reality to the beautiful glowing map of the observable universe that we just spent so much time building. Our telescopes, like the James Webb Space Telescope, can see incredibly distant galaxies, some located over 30 billion light-years away. We can take stunning high-definition photographs of their spiral arms and study their chemical compositions. But you have to remember that light takes time to travel. The light we're seeing from those ultra-distant galaxies left them billions of years ago, back when they were much closer to us, and the universe was much smaller. That ancient light is just arriving now. But in the present day, in the exact moment you're watching this video, those specific galaxies have long since crossed the cosmic event horizon. They are currently receding from us faster than the speed of light. This leads to the invisible majority paradox, arguably the most depressing fact in all of astrophysics. Roughly 97% of all the billions of galaxies we can currently see in the observable universe are already gone. We are staring at a massive, beautiful mirage. They are completely out of reach. Even if humanity somehow invented a magical spaceship tomorrow that could travel at exactly 99.9% of the speed of light, and we flew it directly toward those galaxies, we would never reach them. The space between us would multiply faster than we could cross it. The vast, overwhelming majority of the universe has already been locked away from us forever, hidden behind an impenetrable wall of expanding distance. Out of the entire 93 billion light-year sphere, we can only ever physically interact with the remaining 3%, mostly just our local group and a few immediate neighbours. We are stranded on a shrinking island, taking photographs of a majestic empire that we have already been permanently exiled from. So, it is a slow, agonizing process of cosmic isolation. You can think of the observable universe as a massive, brightly lit room where the lights are slowly, one by one, being switched off, starting from the edges and creeping inward. We are sitting in the center, watching the darkness close in around us. There will come a time, billions of years from now, when the expansion is so severe that all those distant galaxies will simply fade to black. The night sky will be completely empty, stripped of all its brilliant tapestry. Future astronomers won't see a cosmic web. They will see nothing but an endless, suffocating blackness. They will believe they are entirely alone in the void, and no amount of advanced technology will ever be able to prove them wrong. The universe is actively erasing its own grandeur, sealing us inside a dark, inescapable bubble of our own making, and this is exactly where the foundational logic of our cosmic maps completely falls apart. To understand how this horrifying cosmic isolation will eventually end, we have to look back at the mysterious force actively tearing the universe apart. At the end of the previous chapter, we established that the foundational logic of our cosmic maps is fundamentally flawed. We spent centuries building powerful telescopes to draw a stunning, intricate map of the observable universe, tracing the glowing filaments of the cosmic web all the way to the cosmic microwave background. But that entire map is a grand illusion. It is like carefully drawing a highly detailed floor plan of a massive mansion. only to realize that the mansion is currently burning to the ground and the rooms you mapped have already been reduced to ash. Because of the cosmic event horizon, 97% of the galaxies on our map are already permanently disconnected from us. The light we capture in our telescope mirrors is essentially a collection of cosmic fossils. We are not studying a living, breathing universe, we are meticulously cataloguing a graveyard of ghosts. The map is obsolete the moment we draw it, because the territory itself is rapidly running away from us. Humanity naturally rebels against this idea. We are conditioned by science fiction and our own history of relentless progress to believe that technology can conquer any barrier. We assume that one day, thousands or millions of years from now, we will become a Type 3 civilization on the Kardashev scale. We imagine harnessing the energy of entire star systems, manipulating gravity, and building massive spacecraft capable of traveling at 99.9% of the speed of light. But the heartbreaking reality is that no amount of engineering, no level of technological mastery can ever beat the fundamental expansion of space. Let's use a mechanical analogy. Imagine you're running on a treadmill. No matter how fast you pump your legs, you can never reach the front of the machine if the treadmill belt is accelerating backward faster than you can sprint. It doesn't matter how perfectly you optimize your running form. The expansion of space is that accelerating treadmill. Even at the absolute speed limit of the universe, our most advanced theoretical spacecraft would just be running in place, helplessly watching the distant galaxies fade into the dark. We are permanently confined to our 3% of the universe, the local group, and there is absolutely no scientific loophole that will ever let us out. We can map the remaining 97%. We can give those distant galaxies names, categorize their shapes, and measure their chemical output. Or we can write thousands of academic papers about their history. But we can never touch them. They are functionally separated from our reality. This forces a profound psychological shift in how we view our place in the cosmos. We are not the future conquerors of the universe. We are merely its temporary isolated observers, watching a grand play from a balcony seat, with doors that have been permanently locked from the outside. But what exactly is powering this accelerating treadmill? For a very long time, the greatest minds in astrophysics believed that the expansion of the universe would eventually slow down. It made logical sense. The Big Bang provided the initial explosive push outward, but the collective gravity of all the billions of galaxies, stars, and black holes should act like a giant cosmic brake, slowly pulling everything back together. But in 1998, two independent teams of astronomers studying distant supernovae made a discovery that completely shattered our understanding of physics. They realized that the expansion of the universe was not slowing down. It was speeding up. Something incredibly powerful, completely invisible, and fundamentally repulsive was actively pushing the fabric of space apart, easily overpowering the gravitational pull of all the matter in the universe combined. Scientists named this terrifying, mysterious phenomenon dark energy. It is arguably the greatest unsolved mystery in all of modern science. We call it dark not because it is literally black, but because we are completely in the dark about what it actually is. Despite the fact that we cannot see it, touch it, or interact with it in any way, calculations show that dark energy makes up roughly 68% of the entire universe. Normal matter, every star, planet, galaxy, and human being that has ever existed, makes up less than 5%. We are a microscopic impurity in a universe dominated by an invisible repulsive force. And the most terrifying property of dark energy is that it seems to be an inherent property of empty space itself. This creates a catastrophic feedback loop. As the universe expands, it creates more empty space. More empty space means more dark energy is generated. More dark energy pushes the universe apart even faster, creating even more space. It is a runaway cosmic train with no brakes accelerating exponentially toward a dark, freezing abyss. This runaway acceleration leads us to the destiny paradox, the ultimate unavoidable fate of our universe. Because of dark energy, the future of the cosmos is profoundly bleak. As the expansion of space continues to accelerate over the next several billion years, the cosmic event horizon will shrink. Right now, we can see galaxies up to 46 billion light-years away, even if we can never reach them. But eventually the expansion will become so fast that the light from those distant galaxies will no longer be able to reach us at all. One by one, like candles being blown out in a massive dark hall, the galaxies of the cosmic web will cross the horizon and vanish from our night sky forever. Trillions of years in the future, the night sky of Earth, or whatever planet our descendants might inhabit within the merged Mil-Comma-Do galaxy, will be completely, utterly black. There will be no glowing filaments, no distant spiral arms, and no cosmic microwave background radiation. The expansion of space will have stretched the ancient light of the Big Bang so far that its wavelengths will become infinitely long and completely undetectable. If a new intelligent civilization were to evolve on a distant planet inside Mil-Comma-Do at that time, they would look up at the sky through their most powerful telescopes and see absolutely nothing but their own local stars. Because all the evidence of the wider universe will have been pushed beyond the event horizon, these future scientists will have a completely flawed understanding of reality. They will logically conclude that their single galaxy is the entire universe, floating alone in an infinite, static, and eternal void. They will have zero physical evidence that the Big Bang ever happened, that the universe is expanding, or that billions of other galaxies once existed. The universe is essentially a self-erasing hard drive. It is actively deleting the physical evidence of its own glorious history, ensuring that future generations will be trapped in a state of permanent, inescapable ignorance. And it doesn't stop there. The relentless push of dark energy guarantees that the universe will end in a scenario known as the Big Freeze. Eventually, the stars in our isolated galaxy will burn through all their nuclear fuel and violently die. The gas and dust required to form new stars will be completely exhausted. The universe will become a graveyard of dead white dwarfs, silent neutron stars, and massive black holes. Even the black holes will eventually evaporate into nothingness through Hawking radiation. The universe will reach a state of maximum entropy. It will be a cold, dark, and perfectly uniform void where the temperature approaches absolute zero, and absolutely nothing happens forever. Time itself will lose all meaning because there will be no events, no motion, and no consciousness left to measure its passing. There will be no light, no heat, and no memory that humanity or any other civilization ever existed. Mind us, everything that we have ever built, every war we have fought, every beautiful piece of art we have created, and every scientific discovery we have painstakingly made will be completely erased in the dark. The universe will not remember us. It will simply continue to expand, cold and dead, into an eternal, silent eternity. This is the ultimate nihilistic reality of astrophysics. The universe does not care about our existence, and it has already mathematically guaranteed our total erasure. And while this ultimate, freezing cosmic death might logically seem like the final chapter of our story, the true descent into madness is actually just beginning. To fully grasp how terrifyingly empty this expanding universe really is, we have to look past the physical borders of our own reality. In the previous chapters, we meticulously constructed a horrifying map of our reality. Or we started at Earth, zoomed out to the local group, passed through the glowing filaments of Laniakea and the cosmic web, and finally hit a solid, unyielding barrier. We called it the cosmic microwave background. We established that this glowing wall of ancient radiation, sitting 46.5 billion light-years away in every direction, represents the absolute impenetrable edge of the observable universe. It is a spherical cage with a diameter of 93 billion light-years, containing roughly 2 trillion individual galaxies. For all of human history and for most of our modern scientific era, we have treated this massive sphere as if it were the entire universe. We talk about it, study it, and measure it as if it encompasses everything that exists. But this is the greatest optical illusion in the history of science. The 93 billion light-year sphere is not the actual universe. It is simply the observable universe. The word observable is the most crucial, terrifying caveat in all of astrophysics. The cosmic microwave background is not a physical brick wall marking the edge of space. It is not a barrier of fire, and it is not a glowing fence separating existence from a dark, empty void. It is simply a horizon of time. It is the absolute limit of what we are physically allowed to see because of the finite speed of light and the finite age of the cosmos. Since the universe is only roughly 13.8 billion years old, light from any object further away than that simply hasn't had enough time to reach our telescope mirrors yet. The boundary is an artifact of our specific position in space and time. Imagine standing on a small boat in the exact center of a vast, foggy ocean. You can only see the water immediately surrounding your boat up to the point where the fog becomes too thick to see through. That small circle of visibility is your observable ocean, but you know with absolute certainty that the ocean does not magically stop where the fog begins. The water continues. If you were to instantly teleport your boat 10 miles into the fog, you would find yourself sitting in the exact center of a brand new circle of visibility. You would be surrounded by the exact same water, waves, and horizon. The universe works in exactly the same way. If you could somehow pause the relentless expansion of space and instantly teleport yourself 1 single inch past the glowing wall of the cosmic microwave background, you would not step outside the universe. You would simply step into more universe. You would find yourself surrounded by a completely different cosmic web, filled with billions of new alien galaxies that have never ever been seen by human eyes. You would be standing in the center of a brand new 93 billion light-year sphere of light. This terrifying realization brings us to the most daunting question in human history. If the observable universe is just a temporary bubble of light, exactly how big is the actual total universe that lies beyond the fog? To answer this, physicists have to look back to the very first fraction of a second after the Big Bang, to a violent process known as cosmic inflation. Immediately after the universe exploded into existence, it did not expand at a slow, steady, or predictable pace. For a microscopic fraction of a second, a window of time so unimaginably small that it requires dozens of zeros just to write it down, the early universe expanded at a rate that completely defies human comprehension. During this brief, violent period of inflation, the physical fabric of space itself stretched faster than the speed of light by an astronomical magnitude. It took a microscopic, dense point of energy and instantly violently inflated it into a macroscopic cosmos. The inflation eventually stopped in our local area, allowing energy to cool down and form the galaxies and stars we see today. However, the sheer scale of that initial stretching process created a universe that is vastly, horrifyingly larger than the small pocket of light we currently inhabit. Because we cannot physically see past the cosmic microwave background, we cannot just take a ruler and measure the total size of the universe. However, astrophysicists are incredibly clever. Even though they cannot see the edge, they can calculate the minimum possible size of the total universe by meticulously measuring the geometric shape of the space we live in. To understand how this works, think about the planet Earth. When you stand in a massive open field or look out over a calm ocean, the ground beneath your feet appears completely flat. For thousands of years, our ancient ancestors logically assumed the Earth was a flat plane because their localized perspective couldn't detect any curvature. The sphere of the Earth is so massive compared to the tiny size of a human being that the horizon looks like a straight line. You have to zoom out significantly, either by climbing a high mountain or launching into orbit, before the curvature of the planet finally reveals itself. Astronomers applied this exact same principle to the entire universe. According to Einstein's theory of general relativity, the massive amount of matter and energy in the universe should cause the very fabric of space-time to warp and curve. The universe could be curved like a sphere, meaning if you travelled in a straight line for long enough, you would eventually wrap around and return to your starting point. It could also be curved like a saddle, bending infinitely outward. To find out which shape we live in, astronomers pointed our most advanced satellites, like the Planck spacecraft, directly at the cosmic microwave background and measured the tiny temperature fluctuations in that ancient light. They were looking for the microscopic distortions that would reveal the curvature of the cosmos. What they found was absolutely chilling. The data from the Planck satellite reveal that the universe does not appear to curve at all. To a margin of error of just 0.4%, the observable universe is mathematically perfectly flat. Just like an ancient human standing in a field, our entire 93 billion light-year observable sphere is completely flat. But we know from physics that the universe must have some curvature. The fact that it appears perfectly flat to our most sensitive instruments implies something profoundly terrifying about its true scale. It means the entire sphere of our observable universe is incredibly microscopically small compared to the total size of the cosmos. We are like an ant standing on the surface of a sphere so unimaginably massive that the curve is completely undetectable. If we take the tiny margin of error from the Planck satellite data, that 0.4%, and calculate the absolute minimum size the universe must be in order to appear this flat, the result is staggering. The mathematics dictate that the total unobservable universe must be at least 250 times larger than our observable bubble. Let's pause and truly process that number. Our observable universe is 93 billion light-years across. It contains 2 trillion individual galaxies, each containing hundreds of billions of stars. If the total universe is just 250 times larger than that, it means our entire map of reality represents less than 0.5% of what actually exists. It means there are over 500 trillion galaxies hiding in the dark, forever beyond our reach, engaged in their own cosmic dances, completely unaware of our existence. But that is just the absolute conservative minimum. Many theoretical physicists, including Alan Guth, the brilliant scientist who originally pioneered the theory of cosmic inflation, believe the true size of the universe is much, much larger. According to the mathematics of inflation theory, the brief, violent stretching at the beginning of time didn't just make the universe 250 times bigger. It made it exponentially larger. The estimates from inflation theory suggest that the total universe is at least 10 to the power of 23 times larger than the observable universe. This number is a 1 followed by 23 zeros. It is a scale so utterly monstrous that the human brain completely short-circuits when trying to visualize it. Let's use a radical analogy to force our brains to comprehend this nightmare. Imagine you could shrink the entire 93 billion light-year observable universe down to the size of a single, microscopic atom. Everything we have ever seen, every star, every galaxy, every black hole, all compressed into one tiny atomic dot. On that incredibly reduced scale, where our entire known reality is just an atom, the total unobservable universe would be the size of the entire Milky Way galaxy. You are living inside a single atom, floating in a galaxy made of trillions of other identical atoms. Beyond our wall of light, there is a sprawling infinite ocean of galaxies, superclusters, and cosmic voids that we will never map, never see, and never touch. The sheer volume of this invisible reality renders humanity, our planet, our solar system, and even our entire observable universe statistically equivalent to absolutely nothing. But there is a final, even darker possibility that we must confront. What if the universe is not just unfathomably large? What if it doesn't have an edge at all? What if the universe is truly, mathematically infinite? Many cosmologists believe that space simply goes on forever, without any boundaries, without any walls, stretching infinitely into the dark. While the word infinite is casually thrown around in conversation, in physics, infinity creates a horrifying set of logical paradoxes. If the universe is truly infinite in size, it completely shatters the concept of individuality. Think about the fundamental building blocks of reality. The universe is made of a finite number of fundamental particles, quarks, electrons, and photons. In any given volume of space, such as our observable universe, there is a strictly limited number of ways that you can arrange these particles. It is an incredibly massive number, but it is not infinite. You can think of it like a deck of playing cards. There are a massive number of ways to shuffle the deck, but eventually, if you shuffle the cards an infinite number of times, you are mathematically guaranteed to repeat the exact same order. If the universe is infinite and the laws of physics are uniform throughout it, then every possible arrangement of matter and energy must eventually repeat. It is a mathematical certainty. If you travel far enough through an infinite universe, you will eventually find a region of space where the cosmic dust collapsed in the exact same way it did here. You will find an identical Milky Way galaxy. Inside that galaxy, you will find an identical solar system with an identical Earth. And on that identical Earth, there is an exact atom-for-atom copy of you. They have lived your exact life, made your exact mistakes, and are currently sitting exactly where you are, watching this exact same video. In an infinite universe, there isn't just one copy of you. There is an infinite number of you, playing out every single possible variation of your life, forever, across an endless ocean of space. The concept of a unique, special human existence is completely obliterated by the brutal mathematics of infinity. We are not a special creation, we are simply a statistical inevitability playing out on a loop in a dark, boundless room. This is the ultimate mind-bending horror of the macro scale. We are trapped in a microscopic bubble of fading light, surrounded by an infinitely repeating graveyard, forced to watch the galaxies run away from us faster than the speed of light, entirely powerless to stop it. And this is exactly where the foundational logic of our entire human existence completely falls apart. To understand our true, defiant significance in the cosmos, we first have to look at how humanity actively responds to absolute mathematical despair. We have spent the last hour dissecting the horrifying, inescapable reality of our existence. We have established that the vast majority of the universe is permanently locked away behind the cosmic event horizon. We have proven that the universe is aggressively accelerating toward a cold, dark, and utterly silent death. Faced with this overwhelming nihilistic nightmare, the most logical and mathematically sound response would be for humanity to simply give up. We should accept our fate as prisoners in a microscopic bubble, put our heads down, and stop looking up at a sky that is actively running away from us. But humanity is not a logical, easily defeated species. When faced with the insurmountable, suffocating darkness of the infinite void, we didn't lower our eyes. We doubled down. We became aggressively, beautifully obsessed with the dark. We decided that if the universe was going to eventually erase itself, we were going to build the most magnificent machines in history to watch it happen. Perhaps the greatest testament to this defiant human spirit occurred in 1995. Or, imagine you were an astronomer at the time operating the Hubble Space Telescope. You decide to do something that many respected scientists considered to be an absolute foolish waste of incredibly expensive telescope time. You point humanity's most powerful optical instrument at a completely empty pitch-black patch of sky near the constellation of Ursa Major. The area you chose was unimaginably small, roughly the size of a single pinhead held at arm's length against the night sky. There were no known stars there. There were no glowing gas clouds. It was completely, utterly dark. You open Hubble's lens and leave it staring into that specific abyss for 10 consecutive days, capturing whatever faint photons of light happened to drift across the void. When they finally processed the image, the result completely shattered our understanding of astrophysics. That tiny, supposedly empty black patch of sky was not empty at all. It was absolutely overflowing with ancient, majestic light. The resulting photograph, now famously known as the Hubble Deep Field, revealed over 3,000 distinct, fully formed galaxies. Let that sink in for a moment. 3,000 entire galaxies captured in a patch of sky the size of a grain of sand. Each of those 3,000 smudges of light was a massive island containing hundreds of billions of stars, thousands of planets, and potentially countless intelligent civilizations, all packed into a microscopic sliver of the heavens. The deep field image proved an intoxicating, terrifying truth. No matter where we look in the cosmos, even in the darkest, most aggressively empty corners of the void, the universe is practically bursting at the seams with majestic structures. We just didn't have eyes sensitive enough to see them. Following this success, astronomers repeated the experiment, staring even deeper, for even longer, creating the Hubble Ultra Deep Field and the Extreme Deep Field, discovering that the rabbit hole of galaxies simply never ends. But even Hubble, for all its revolutionary power, was ultimately limited by the mechanical laws of the universe. As we discussed earlier, the rapid expansion of space physically stretches the light traveling through it. The ancient light emitted by the very first galaxies in the universe has been stretching for over 13 billion years. By the time the ancient light finally reaches Earth, its wavelength has been stretched so far that it falls completely out of the visible light spectrum. It becomes infrared light, which human eyes and the Hubble Space Telescope simply cannot detect. The oldest ghosts in the universe were completely invisible to us, so humanity decided to build a better eye. We spent decades and $10 billion constructing the James Webb Space Telescope. We built an engineering masterpiece featuring a massive gold-plated mirror designed specifically to capture the invisible heat of infrared light. We launched it 1 million miles away from Earth and chilled its sensitive instruments to near absolute zero, just to ensure that the intense heat of our own planet wouldn't completely blind it. Today, the James Webb Space Telescope is actively pulling back the heavy, impenetrable curtain of the cosmic dark ages. It is looking back over 13 billion years in time, successfully taking baby pictures of the infant universe. It is watching the very first stars ignite in the dark, piercing the thick, suffocating clouds of primordial dust that have hidden our origins since the beginning of time. Webb is not just taking beautiful pictures, it is fundamentally rewriting the textbooks of astrophysics. It is finding massive, fully formed galaxies existing at a time when the universe was barely a toddler, confusing our most brilliant scientists and challenging everything we thought we knew about how the cosmos evolved. Every time James Webb points its golden mirrors at the sky, it forces humanity to confront the overwhelming, intricate complexity of a universe that is far older and far stranger than we ever dared to imagine. And we didn't just build mechanical eyes to stare into the abyss, we also built fragile metallic messengers to physically sail into it. Let's return to the Voyager spacecraft, which we discussed earlier in our journey. While James Webb looks backward into the deep past, Voyager 1 and 2 are actively pushing outward into the terrifying future. They are our tiny, fragile metallic bottles thrown into an impossibly vast, violently hostile ocean of radiation. Attached to the side of each Voyager probe is a golden record, a phonetic time capsule containing the sounds of Earth, the music of humanity, mathematical formulas, and greetings in 55 different languages. It is a desperate, beautiful attempt to leave a permanent mark on an uncaring universe. We mathematically know that Voyager will take 30,000 years just to cross the Oort cloud, or we know it will never ever cross the cosmic event horizon. We know it is statistically flying into an eternal graveyard where it will likely never be found by another living soul. Yet we threw our voices into the dark anyway. It is an act of pure, unadulterated cosmic rebellion. We know the Great Freeze is coming, we know the universe will eventually forget us, but we refuse to go quietly into the dark. We are reaching the end of our terrifying cosmic journey. If you found this video valuable, please like it and leave a comment. Your interaction is the exact signal that tells the algorithm to share this massive project with others. If you want to continue exploring the darkest corners of space with us, make sure to subscribe. Now let's step back and face the final lingering question. Why do we do it? Why do we spend billions of dollars and devote entire lifetimes to mapping a cosmic ghost town that we can never physically visit? Why meticulously catalogue a universe that is actively running away from us? Because the very act of understanding the universe, even if we can never physically touch it, is an act of profound, breathtaking triumph. The universe spent 13.8 billion years operating in complete, unthinking silence. It created trillions of galaxies, ignited septillions of stars, and expanded across 93 billion light-years of space, without a single conscious mind to witness its brutal majesty. But then, on a microscopic wet rock orbiting an aggressively average yellow star, the universe finally woke up. Through the evolution of humanity, the cosmos finally grew eyes to see its own beauty and a highly complex brain to comprehend its own terrifying scale. We are the universe's unique biological way of thinking about itself. Our fragile physical bodies may be permanently trapped inside the gravitational prison of the local group, doomed to eventually merge into Milkommer, but our minds have successfully conquered the entire 93 billion light-year sphere. We have mathematically weighed the supermassive black holes anchoring distant superclusters. We have precisely charted the invisible, sprawling rivers of dark matter that dictate the shape of the cosmic web. And we have listened to the fading ancient microwave echoes of the Big Bang itself. We are a microscopic species that has somehow managed to decode the source code of reality. In a universe dominated by mindless, violently expanding dark energy and crushing physical isolation, the fragile, flickering light of human curiosity is arguably the most remarkable and precious phenomenon in existence. We are the conscious observers of the void. We successfully built the ultimate mechanical eyes to pierce the cosmic dark, only to realize we are staring directly at our own inevitable grave. To understand why our most brilliant scientific minds still lay awake at night, we have to look back at the gaping, terrifying holes in our cosmic map. Over the course of this journey, we have systematically charted the sheer scale of the observable universe. We have confronted the cold, isolating destiny paradox, and we have celebrated humanity's desperate, beautiful attempt to hurl optical instruments and metallic messengers into the infinite dark. But despite all of our mapping, despite the $10 billion telescopes and the massive supercomputers crunching geometric data, we must acknowledge a deeply uncomfortable truth. The more we look out into the void, the more we realize that our fundamental understanding of reality is practically non-existent. We have built an incredibly detailed map, but we are completely blind to the paper it is drawn on. This brings us back to the mysterious invisible forces dictating the fate of our cosmos. Earlier, we established that dark energy is the repulsive force actively tearing the universe apart, acting as the accelerating treadmill of space. But dark energy is only one half of the ultimate cosmic mystery. It makes up 68% of the universe. Another 27% is composed of something equally terrifying, known as dark matter. If dark energy is the repulsive wind blowing the universe apart, dark matter is the invisible glue desperately trying to hold it together. When astrophysicists study how fast galaxies spin, the mathematics simply do not work. There is not enough visible mass, not enough stars, planets, and gas to generate the gravity required to keep the galaxies from violently flying apart. There is an invisible skeleton holding the entire cosmic web together, and we call it dark matter. To understand how little we actually know, let's use a theatrical analogy. Imagine you're sitting in a dark theatre watching a beautifully choreographed puppet show. You can see the wooden puppets dancing across the stage, and you can map their movements perfectly. The puppets are the stars, the planets, and the glowing galaxies. But you are completely incapable of seeing the invisible strings pulling them together, which represents dark matter. And you're equally blind to the massive invisible fans blowing the entire stage apart, which represents dark energy. You're only watching the 5% of the show that is made of normal matter. The remaining 95% of the universe is completely dark, untouchable, and unknown to us. The word dark in these theories isn't a descriptive scientific property, it is a linguistic placeholder for our own profound ignorance. We have mapped the glowing cities of the cosmos, but we have absolutely no idea what the ground is made of, or what is causing the tectonic plates to shift. This effectively closes the loop on our grand attempt to conquer the cosmos. We are passengers on a runaway train, and 95% of the train is completely invisible. But the mysteries don't stop at the composition of space. When we try to look backward to the absolute beginning of everything, our physics completely breaks down. We know the Big Bang happened 13.8 billion years ago, but the human brain inherently demands to know what happened before it. What triggered the explosion? What existed in the infinite eternity before the first second? The terrifying answer from modern physics is that the question itself is mathematically invalid. According to general relativity, time and space are woven together. The Big Bang didn't just create matter, it created time itself. Asking what happened before the Big Bang is like standing exactly on the North Pole and asking someone to point north. The concept of before simply does not exist. The cosmic curtain is drawn shut, and the mathematics of the universe physically forbid us from ever looking behind it. And if we cannot look before the universe, what happens if we try to look outside of it? What exactly is our 93 billion light-year sphere expanding into? Again, our intuition fails us. The universe isn't a balloon expanding into a larger empty room. It is creating space itself as it expands. However, some theoretical physicists believe our reality might just be a single, microscopic bubble in a boiling pot of cosmic foam. In this terrifying scenario, the Big Bang was just one localized pop in an eternal, infinite ocean of chaotic inflation. This process creates an endless sea of separate, isolated bubble universes. Each of these infinite bubbles could possess its own entirely different laws of physics. In some bubbles, gravity might be so strong that stars instantly collapse into black holes. In others, atomic bonds might not exist at all, leaving a universe filled with nothing but cold, formless radiation. We are completely isolated in our specific bubble, perfectly tuned for human life, but permanently walled off from the infinite boiling reality that surrounds us. We have finally mapped the absolute boundaries of our physical cage. But this beautiful, glowing cosmic map is merely a comforting distraction from the true, unfathomable horror waiting outside. To understand our ultimate place in this terrifying architecture, we first have to embrace the profound weight of our own cosmic isolation. We have reached the absolute end of our journey through the observable universe. We have fully explored our initial promise, discovering exactly what the observable universe really is, and why the galaxies we see at its edges are physically impossible to ever reach. We have zoomed out from the microscopic grain of sand that is Earth, navigated through the sprawling superclusters of the cosmic web, and physically mapped the impenetrable barrier of the cosmic microwave background. We have confronted the horrifying reality of dark energy, the invisible runaway train actively stretching the fabric of space. It is mathematically guaranteed to push every distant galaxy beyond our event horizon, sealing humanity inside a dark, freezing bubble forever. The destiny paradox ensures that we are permanently trapped within our 3% of the universe. For many, this realization is profoundly depressing. It triggers a deep, existential dread, a sense of crushing insignificance in the face of an uncaring infinite void. But this feeling of cosmic dread is entirely a matter of perspective. When you look at the sheer, terrifying emptiness of the universe, you can choose to feel small, or you can choose to feel incredibly, unimaginably rare. Let's use a biological analogy. Imagine you're wandering through a completely barren, lifeless desert composed of nothing but grey dust and jagged rocks, stretching unbroken for millions of miles in every direction. If you were to suddenly stumble upon a single, perfectly blooming bright red rose growing out of a crack in a stone, you wouldn't think the rose was insignificant just because the desert is large. You would realize that the rose is the most precious, vital, and beautiful object in the entire landscape, specifically because it is so rare. The vastness of the desert doesn't diminish the rose, the vastness makes the rose a miracle. Humanity is that single, fragile red rose blooming in an impossibly vast, dead cosmic desert. As far as we can currently observe, the universe is a cold, silent, mechanical system of nuclear fusion and gravitational collapse. It does not think, it does not feel, and it does not care. But we do. We are the mechanism by which the universe finally woke up. The atoms in your body were forged in the incredibly hot, violent cores of ancient dying stars, cast out into the void, and eventually reassembled on this tiny blue planet into a conscious, breathing human being. You are the universe's unique biological way of experiencing its own majesty. When you look up at the night sky and feel awe, that is the cosmos finally appreciating its own terrifying beauty. Every scientific discovery we make, every telescope we launch, and every mathematical equation we solve is an act of defiance against the silence. It is a declaration that even though the universe is destined to freeze and fade away, we were here and we understood it. This realization transforms our cosmic isolation from a curse into a profound, breathtaking responsibility. We are the lone custodians of consciousness in our microscopic corner of the dark. If we allow ourselves to be destroyed by our own petty terrestrial conflicts, if we let tribalism, war, or ignorance extinguish the flickering light of human curiosity, the universe will simply go back to being dark, silent, and meaningless. We owe it to the cosmos and to the billions of years of violent evolution that created us to survive. We must push beyond the confines of Earth, explore the outer limits of the local group, and ensure that the flame of conscious thought continues to burn against the dying of the light. We are small, yes, but we're also the most important thing in the observable universe. We have successfully mapped the terrifying boundaries of our cosmic prison, but the true battle is ensuring our fragile light never burns out in the dark. The universe may have locked us in a dark, rapidly expanding cage, but we have refused to be silenced. We will keep observing, calculating, and reaching out right up until the very last star fades away. And you? Where in the world are you watching the sky from tonight, and what can you see above your roof? Tell us in the comments, along with the time where you are. If you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. The next episode of The Edges of the Sky takes us to the black hole paradox,